Okay, so the plan for today and next Monday, we're going to finish one single lecture just to give you the very basics about how you do elementary programming in Java, which will contain many ingredients over there. So for today, I'm going to give you the most important concept, which is more about development process for your Java code, which might be quite different from what you did in 10.11. But that's something I will try to give you intuition. All right, so now let me just go to the slides, which is already on the line. You can open that on your laptop if you like. So now let's go learning outcomes for this lecture. We're going to talk about ingredients for elementary programming. So these are the things we're going to talk about. Let me just enumerate them very quickly, but they will gradually make sense as we go through the lecture. We got data types. So data types, keep in mind, this is the single most important concept for this course. Because in Java, we got a notion of types. And if you don't really get the types correct in your program simply cannot be run. It is so-called a type error. We'll see lots of examples throughout your labs and also the lecture. Okay? And data types, but we'll go over them today, just a few examples. And we got literal values, which if you have followed through the tutorial for Lab 0 Part 1, you have seen literal values. And we got something called constants, which I will explain, versus variables. So variables is really the thing you want to get used to. Somehow you don't just want to manipulate explicit values verbatim directly. You want to manipulate things symbolically. That's how you can express complicated programs. Okay, and then operators. We're going to learn about just today arithmetic and relational. So these correspond to just your mathematical classes from the high school. So these are not difficult. But next time, either next Monday or Wednesday, if you want to get more complicated control structure work, like if statements or loops, you have to learn about something called Boolean values, which may not exist in MATLAB. I'm not too sure. But anyway, we'll get to it. And we got expressions, which is something you want to build as complicated as you need. Okay, we'll get there too. And input and outputs. So you also learn about input and output. How do you do output? System.out.println. How do you do input? You simply just do a scanner and then input on next int, for example. One thing to note, the way we do output right now, we made it explicitly very simple for you. You simply output to the console. But later on, there is a more complicated mechanism to passing output. Simply internally within your program, you want to pass input from one part to another. That's something called return values for methods, but we'll get there. Okay, not that soon. And now, this is something I want to keep that in mind. In this course, we're going to teach you computational thinking. Given a problem, don't be so keen to dive into coding right away. Always think about how I can solve this abstractly, mathematically, before you translate it into Java. And this pattern over here is going to be useful not just for this course. Later on, you'll learn about C, you learn about Python, you learn about C# or any other new language. This is really the pattern. You don't want to dive into code. Code is only about syntax. It's really your thinking that matters. Okay? That's something we'll keep emphasizing. Okay? So now, let me just review something very quickly and we'll get to the new stuff. And then I'll talk about workflow for you. Entry point of execution. So this is kind of the structure you can assume for the next maybe at least the next month. Except for the lab test, which I'll give you some tutorial video to study. But now, to really get you started, you can always assume. You can create a class without any problem. You can also check the box to create a main method. That's also no problem. For now, please just take these two lines for granted. You don't have to understand just yet what they really mean. We can only learn about what these two lines really mean until we talk about classes and objects, maybe after the reading week. Okay, but for now, assume these two lines. However, now within this block over here, this is where you define your steps. You know, sequential composition of assignments, if statements, loops, etc. That's something we'll focus on for the first month. And then the main method, okay, starting point of execution, and now sequential execution. I mentioned that in the tutorial video. Let me say that again. It's really important. How do you anticipate the behavior of your program? Easy. Top to bottom, and then one line after another. That's how they execute a line at the runtime. Okay? And later on, for this lab, the coming lab for Lab 0 Part 2, I'm going to show you a particularly useful concept for you as a programmer. It is something called debugger in Eclipse. That's really a way to slow down the way computer execute your program. You can really see step by step how things happen. That's something I will give you a tutorial video to study for. And then you will illustrate that to the TA. It'll be a very, very valuable thing for you to do as a programmer. Okay, now that's good. So far so good. And then it terminates. Now, let's talk about some process. I'll show you a bigger diagram, but it's on your slides. Basically, I want to make it very clear for you as a programmer, you have to understand what kind of errors can you run into throughout your career, not just for this course, okay? Let me give you some concept over here. So now let me switch to iPad over here, and then I will switch to very quickly to mention, I forgot the announcement. Okay, for office hour, I got it today, Wednesday, 3 to 5 p.m. If you want to speak to me, feel free to go to my office. And for Lab 0 Part 1, you still got Wednesday today, 6 p.m., and also Friday, 5:30 p.m. Please do come and get graded and get help. Beyond this week, we don't grade it anymore. We got to move on to the next part. And if you want to do more exercises, I suggest you go to this particular website. It's called Coding Bat. Bat, you know, as in baseball. Okay, Coding Bat. They got lots of exercises in Java which you can learn. Okay? If you are struggling with how to use a website, drop by my office hour, I will show you. It's a very valuable reference for you. All right. Good. Now, what about the development process over here? So now, let me just go through all the steps you have to go through throughout the semester. Okay? Always keep this diagram in mind. So every time when I say it's a syntax error, when I say it's a type error, when it's a logical error, I do mean what I mean. So you want to know exactly what I mean, right? Let's see this. Let's just go for the flow together. You have actually experienced that quite a bit already. I'll give you an example for each one of them. Let's go over step by step. Number one, whenever you create a new Java class, something.java, that means you start your developments in the editor of Eclipse, right? You can just type. And that's the editor for Eclipse. You can definitely write lines of code, as many lines as you find necessary. Now, as soon as you click on Control-S to save your file, Eclipse is going to do so-called compilation for you, okay? It's going to do a process of compilation. Compilation intuitively simply means the computer, Eclipse is simply just going to analyze the Java code you just wrote, and then to see if there's any problem, okay? However, there's different kinds of problems that the Eclipse can detect. Let me just go over them with you. The easiest way to see it, I'll just go over each one by one and give you an example. For the first stage, Eclipse is just going to compile your program. Okay? If the program somehow got compilation error, it can be basically two kinds. Either it can be a syntax error, or it can be a type error. Let's see examples right away. We only talk about compilation, okay? Let's see on the slides. So now we talk about basically two stages of your program, compilation time and runtime. So now we are focusing on compilation for the moment. The thing is, if you don't even pass the compilation check, you cannot even go to the runtime. Your program just cannot be executed, okay? So now let's see the compile time. So when you try to edit your program in Eclipse, it's the compile time. And then there are two kinds of compile time error. Let's go over that and then give you an example. Syntax error, it simply means you just specify some Java program that's not grammatically correct. For example, missing a semicolon. Or it didn't really include the closing curly brackets, right? As we show in the tutorial video. I'll show you an example right away. Okay, that's the, and only for your reference, you don't have to read this. Maybe just for your interest. If you click on this link, it contains the complete grammar for Java. You can think about Java is like a language, just like English. If you don't really even have your grammar correct, for us as a human, we might be flexible to understand the language you're speaking. But for computer, they are not flexible. The syntax has to be 100% correct. Let's see example. Example number one, I'll show you a screenshot and then I'll show you on Eclipse. Example number one for compilation error. It is so-called syntax error, okay? Let's see over here, and all the source code I'm demonstrating now, I'll make it available to you after class. You can also play with them. Now, number one thing to note, whenever you're opening a tab on Eclipse, right, you want to notice that if you have a star like this, that simply means your program is unsaved. In that case, you must make sure you save your file so that your program so far can be analyzed by the Eclipse, okay? As soon as you click on save, and then the star will go away. Now, there are two possibilities when the star goes away after you save it. Either you have a red check mark over here, right? You have seen this already from your tutorial. That simply means there's some error in your program in this compilation stage. And typically, it can be either syntax error or type error. In this case, we got a syntax error. Can we tell what the syntax error is? That's the number one common thing you have. You don't have a semicolon. That's the number one thing you have. Hopefully, you can get rid of it from lab test 1. Okay? Okay, that's number one, example 1. Example 2. Let's have a look at this. Well, this one's a bit trickier. Actually, I saw one of you guys writing this program in the lab. That's why I'm including it. Okay? Now, over here, again, you can see that there's a red check mark, which means it's not good. If you see there's a red check mark, go to another check mark within the class. It tells you where exactly it is. Now, you can see that it's around this place. That's something wrong. Well, you can see that we are trying to say hello. We have some starting quotes. There's no ending quote. That's a problem. That's also very common. Okay, symmetry is really important. Okay, any questions so far? Okay, number 3. Another syntax error. This one is a little bit trickier, but that's also very common. Okay, again, symmetry is very important. That means over here you can see there's something wrong with this particular class around this line, around, not necessarily exactly this line. So now this is my hints to you. Whenever you see there's some error over here around the curly brackets, most likely you're either having some additional curly brackets or you're missing a curly brackets. This is how you can tell conceptually. Okay, you can see that for this particular class, we start with a curly brackets, right? So that means symmetrically, there should be another curly brackets over here. Okay, and similarly, let's see another one here. Okay, we have the main method over here, and then we got the opening curly brackets. But is there a corresponding closing brackets for us? No, that's where the error is. Okay, that's why it's a syntax error. So this is the case where you have fewer curly brackets than you should have. Let's see the opposite case, which can also be an error. Over here, okay, let's see. This one, can you see what the issue is? If you try to apply the same reasoning over here, right? Let's try. Okay, let's be logical here. Okay, I start with curly brackets over here. Presumably, this one should correspond to that. And then I start with another curly brackets over here. Presumably, that should really correspond to that. But somehow, I got an additional closing curly brackets with no corresponding opening curly brackets, right? That's also the syntax error. Okay, so these syntax errors are very, very common. Okay, I hope by the end of next week, don't have these errors. Okay, that's about syntax error. Let me show you one more thing to make my point. So you might think, well, even if I got syntax error, for me as a human, I can see the program and kind of understand what I'm trying to do. I agree with you, but in this course, what you think is not important. How your program writes, how your program behave at the runtime is much more important. Okay, so now let's go to Eclipse over here. Okay, I'll just show you one example. You can play with it as well. Let me just go to the second example, for example. Okay, that's the second example we did where we have an opening quote over here, and then we also got a closing quote over. We don't have a closing quote. That's why there's an error, right? Let's say you simply you just overlook. Ignorance is not going to help, right? Let's say I simply don't care about the error. I try to execute my program anyway. Let's see what's going to happen. Okay. So now this is compile time syntax error 2. I right click on the class, and then I'll simply say run as Java application. Okay, let's see exactly what's going to happen. And one thing I want to also encourage you to actually do, every time you see anything goes wrong in the console, don't be too terrified to read the error message. Oftentimes, they are very useful. They're very informative. Okay, just try to read it. Let's now run it as Java application over here. Okay, and you will simply say there are errors in your project. Do you want to go on? Just say go on. Just ignore that. Okay, just say go on. Proceed. However, you can see now, let's see exactly what they are. Okay, they simply say there's something wrong with your main method over here, and then unresolved compilation problem, which means in the compilation time, there's a syntax error. Your code just cannot be executed. Okay, so this is not very good. Okay, hopefully the message is clear. Okay, that's about syntax error. Let's talk about another kind of error, which will be similar. Basically, every time if you got, let me go back to iPad here, pay 100% attention to red check mark. As soon as you see the red check mark on your class tab, fix it right away. Don't delay. As your program gets too complicated, let's say 500 of line, it might be too late to fix it. You just don't have enough time. Okay? Now, let's go over to the next kind of error. Okay? Now, we just talked about syntax error over here. Let's talk about another kind of error which is called type errors. This one here, it's kind of the second kind of error you will have. Typically, it goes like this. For you to learn a new language, in the first 1 or 2 weeks, syntax errors are really the most annoying things for you to have. After the first 2 weeks, it will be the type errors. After the next 2 weeks, it will be something in the runtime, right? It's just a learning curve. So now let's understand what the type errors are. Here's the principle. Let's say the syntax kind of is correct. You don't have any missing semicolon. You don't have any missing curly brackets. Everything is fine. But still, there's a red check mark on the tab. So this kind of error means you're trying to manipulate the values or data in a way that doesn't make sense. Okay? Let's see one example. So you again. So one example over here. So now, first of all, identify where the error is. Guys, you should notice that even if you're talking in low volume, everybody can hear you. Okay? Thank you. Now, we got type error over here. Now, we know that there is an error over here, this line over here. And now, can you sense about what kind of error this is? Well, over here we say system.out.print line. And then we try to print something. We say York, which is a string, multiplied by 23, which is an integer. That simply doesn't make sense. You're trying to manipulate two values that simply cannot be manipulated together, right? So this is so-called type error, which is a little bit more advanced than syntax error, okay? Which means syntax is absolutely fine, but you're just trying to manipulate your program in such a way that it just cannot be done. What do you mean multiply a string by a number, right? Another case, another example over here. This one is something we're going to talk about also very often as well. So now, you might just be able to answer this actually by watching a tutorial video, right? We learned a little bit informally about how you can declare a variable over here. You can see that we declare an integer variable called I. Initial value is simply 23. And then, what's wrong with this particular line over here? What are we trying to do? Well, you can see that over here, we're trying to say, I want to divide something by 3. But what's that? J. J is presumably a variable, but there's no such variable just yet. You must declare that. Okay, it's also a very common error. Okay, so this is undeclared. Undeclared variable. Just keep all these kind of examples in mind. You will definitely run into them. I guarantee. You'll definitely run into them. Okay? Okay, that's about the type error. Okay. Now, we'll see more and more type errors later, especially when we talk about classes and objects. There will be more. Okay, but just some simple example here. So now, I can say maybe by the end of the first month, you will get a very minimum number of syntax errors and type errors in your Java program. I'm hopeful. Okay? However, the next category of errors are simply the ones you just cannot get rid of. Because we are humans. We make mistakes. Even for myself or somebody who actually win the ACM programming contest, they can still make such errors. Okay? I'm not trying to say there'll be one day you simply don't have any of the second kind of error, but we try to minimize that. Okay? I'll give you a feel. Okay? So now let me just go back to the diagram over here and then just talk a little bit more and then talk about runtime. Okay, let's go back to this diagram here. And you can either have some compilation time error, in which case, what should you do? You go to this particular place, that means it's error, which means you have to go back and fix your code. Save it, make sure there's no red cross. Okay? Now, let's say everything is fixed. No syntax error, no type error. Things can still go terribly wrong. Okay? Let's see. Two kinds of errors at the runtime. First of all, let me tell you both kinds of errors and then we'll do it together. Okay? Do some example. So let's say your program does compile. That means you can run it as Java application. It can be run. Let's say, unfortunately, your program simply crash. Crash, what does crash mean? That means your program somehow terminates, but not terminate in a nice way. Okay, I'll show you what I really mean. Okay, it can be either a runtime exception. So now in Java, whenever you see the word exception, it means something very specific. Okay, exception simply means there's something wrong that happened at the runtime when you try to execute your Java code. Okay, so now I'm gonna talk about exception in just let's talk about exception right away. Okay, and then we'll talk about another kind of error. Now for exception over here, so now runtime exception. Let's have a look at this one. This will be very typical. Let's say we have a class. First of all, is there any compilation error? There's no red check mark, right? As far as you can see over here, you can see that this is clean, which is very good. That means at least your code can be executed, at least, okay? Now, if I try to run this particular fragment of code, do you think it is going to work? Well, you don't even need to know Java. If you look at what I'm trying to do here, division by 0, right? That means it's something that compiler doesn't care. Correct syntax, correct types, you divide integer by integer, but if you try to do it at a runtime, this is what you're gonna have. Let's have a look. Let's go back to Eclipse over here. So let me go to that particular class for you, and let's try to execute the code. Runtime exception.java, okay? Let me just close that one here. If you look at this class over here, no red check mark. It compiles, no problem, okay? Now, what I want to do is to run this as Java application, which means I can run it, okay? Right click. Oh, by the way, if you want to clear the console, you can right click on the console and say clear, okay? That's also a useful tip. If you right click on this particular class and you can say run as Java application, okay? Now, of course, you can say proceed. We got other errors in other classes. Okay, you say proceed. So what we get is we got some exception, which means while we are executing the code, we got some error at the runtime. It is so-called arithmetic exception, which you don't have to worry too much about exception for now. You just know that something goes wrong at the runtime. Okay? Okay, let's go back to your iPad over here, and then let's talk about the next error. Okay. So that's about the runtime exception error. Okay, so now we're saying that if your program crashed, you can have a runtime exception. For example, 10 divided by 0. That's one example here. Now, let's say your program compiles, your program doesn't crash. Does that really mean you got a perfect program? Not necessarily. I tell you what, this error over here, logical error, is the most difficult error to really get rid of. The most difficult one. Nobody in the world can claim that they will always write logically correct program. Nobody can do that. Okay? Let me illustrate to you a very simple example. So logical error over here simply means your program compiles, you can run it, you can also generate some output to you. However, the output it generates is not as expected. Okay? Let's see what I mean by this. Okay, so now let's have a look at one example over here. Now, let's have a look at this example. Okay, you must be very comfortable with this structure over here. Okay, since we did lab 0 part 1 already. Let's have a look. So now this program, first of all, compiles. I can tell you that if you run it, there will be no exception. However, it's simply not correct. Can you see which line? Okay, let's see this. Okay, we simply create a scanner, which is standard way of doing things, and then we prompt the user for radius integer. We read the radius over here. So far, so good. And then we say that over here, the area of the circle is gonna be this expression over here. All right? You can see that everything compiles and everything will run, but is this gonna generate a correct output? No, you apply the wrong formula. Logically speaking, it's not right. Okay, let's illustrate this quickly. Okay, so now let's right click on this particular class. It's called runtime logical error.java. Okay, let's write it and illustrate it to you. So that means if I double click on this class over here, okay, Let me just get everything clean so you don't get confused. Let me clear the console as well. Okay, for this particular class, number one, it compiles. You can see there's no red check mark for that. Okay, let's run it. We run it and make sure we don't have any runtime exception. Okay, what I would do is I'll right click on that and then I'll say run as Java application. And now it's going to prompt me for input over here. So let me make it very simple. If I say 1, the radius is simply just 1. And the area should be 1 squared times 3.14, right? However, it's going to return 6.28, which is simply not right. Okay? You can see if you don't know anything about this program here, if you look at that, you might think it is correct. It compiles, doesn't crash, but it's still not correct. It's not producing the expected output. Okay? So that's the kind of error I'm hoping you can minimize as much as possible. Now, the question for you, the question for me, if the logical error is so critical, how can we minimize that? Okay? I'll write down my answer to you over here. There are two things you want to always do for your program. Okay? How can we get rid of logical error? Okay? To really minimize the logical error, two things you want to do. Number one, you always want to test your program. When I say test, I'm not really talking about very formal test. You will learn about maybe something called JUnits in 2030 later. But for this course, we do something very intuitive for you. You simply print out the output for your program. Try several runs for your program to see if we can generate the expected output. And number two, if you spot an error in your program, how do you know where it is? For simple program like what we did for Lab 0 Part 1, it's very easy to use your eyes to really check it. However, when things get more complicated, especially we got if statements, we got loops, in that case, it will be much more complicated to spot the error. In that case, you need something called debugger. Okay, this might be a brand new concept to you, but I insist we have to learn it. Because for you as a programmer, you have to know how to use debugger to trace your program by yourself manually. Okay? That's something, that's a topic for Lab 0 Part 2, which we'll do over the weekend. Okay? All right, so we got these two, runtime, we got exception, we got logical error. Okay, any questions so far? Are we okay so far? Okay? So now, that's about the, I think it's really worth going through these thoroughly. You really want to keep that in mind as a programmer, really important. Now, let me go to the next slide. Since we know what the expectation for a good programmer is, now let's think about why I will have what kind of expectation I will have on you for the lab test. That's something I deliberately didn't talk about on Monday, because now since you have more sense about compile time and runtime, right? So now that we can talk about it. Again, go back to the diagram over here. Thinking this way, if somehow we try to run your program simply do not compile. All right? That's very bad, right? If we try to run your program, but your program crash, that's also very bad, right? If you try to run your program, and then your program actually doesn't crash but produce something, but that's not quite right, that's also not good. So you want to make sure all the three things are properly handled. Okay, so now here's the thing I will mention quickly, but I'll give you more guidance on how to make get full marks for your lab test. Okay, number one, if your program simply cannot compile, either because you got a syntax error or you got a type error, we're going to be strict. 0. That is why for lab test number 1, I make a very small percentage for you to get used to. We want to make sure when you graduate from this course, you can really write programs that can be run, at least. And it is also correct. Okay, I do have a rationale for that. It's just not because I want to torture you, right? Okay, so what should you do? You want to practice writing as many programs as possible. Okay, that's the solution, the only solution. And now, let's say your program compiles, but it does not quite work right. I would say you definitely get some partial marks for that. That's not a problem. Okay, at least it compiles. However, I would say it may be low marks because if your program compiles but it crashes on every input, or it simply doesn't produce the right output for every input, that's also not very useful. Okay? So now, how can you get over this problem over here? I would say this is really the thing I want you to pay attention to the lecture. I will try to really explain the rationale behind every piece of working Java code or non-working Java code. You want to learn about the logic over there, so you can really extrapolate that to your own programs. Okay? So this is really the slide I want to show you now, so you do know what's going to happen in about 3 weeks' time for your lab test 1. Okay? I'll give you more guidance a little bit later. Okay, now, one more thing to say. You always want to document your code. So there's a reason for that. Okay, you want to say, every time if you want to have some important steps, which you might just forget later, that's something you want to do. I'll show you an example here. Okay, that's also the example you will see throughout my tutorial. Okay, let me show you the general structure here on the iPad. So there are 2 kinds of comments you can add to your Java code. You can add as many comments as you like. So these comments will only be read by programmer, you, okay? And they will not be interpreted by the computer, okay? There are 2 kinds of comments you can write. You can either use // or you can use start with /* and has many star as you like, and end with star and // Okay, we'll do that. We'll let you do it in the lab set tutorial, okay? So just be aware of that. Okay, write as many comments as you can, okay? That's as simple as that. It's a practice you want to do. By the way, in Eclipse, I'll show you one thing that's very cool. So now let's say this. I got this program over here, it compiles. Let's say I want to execute the same program over here, but somehow I want some line to be ignored by the runtime execution engine. What can I do? I can simply comment that particular line out. How do I do that? Okay? Let me show you very quickly. Let's say I simply don't want to prompt the user anymore. We simply wanted to enter right away. Okay? What I can do is I can simply put // You can see now the color changes, right, to green. That means line number 11 is no longer going to be executed. Let's illustrate that. Now, if I try to execute this code over here, just proceed. What you will see is, okay, let me execute it again over here. Okay, let me do it again. If you right-click on this class over here, runtime logical error, and say run as Java application. Okay, and proceed. You can see that over here, there's no more prompt for you. It didn't say enter and the integer radius of a circle, right? That one simply just ignore because it became a comment right now. And then if I say 23, for example, it's still going to read it and tell you some answer, right? But we know that the answer is wrong. Okay, let's go back here. Okay, we're still learning, right? To really respect each other. Okay. Okay, so now let me show you a shortcut very quickly. Let's say, let me go for the extreme case. I simply don't like this piece of code. I don't want anything to be left here. Easy. You can basically highlight everything over here, and there's a keyboard shortcut you can do. Control and // You put everything into comments, okay? And Control / will put it back. Okay, that's something you can try on your lab, on your own examples. Okay, that's about documenting your code. Now, one more thing to say. So why is documentation so important? Beyond this course, when you're trying to write software, you don't necessarily always write the correct software. So you may want to fix your code, or you may want to extend your code with more functionality. In which case, you may forget about how exactly your program works because you wrote it, let's say, a year ago. In that case, you can only rely on the comments to help you, the documentation. Okay? So now, let me go a little bit further. Let's go to the next one. Let's talk about something you have learned already quickly in the tutorial, okay? So now let's learn about the basics for elementary programming. Number one, let's learn about literals. Literal is very easy. You just write out the values directly. So you got character literal. Character literal is something I didn't really mention in the tutorial video. Let me just say it very quickly. Okay, so there's a difference between character versus a string. Okay, so these two are similar concept, but they are very different, or they're somehow different. Okay, if I say a character, you start with a single quote, and then you put something over here, just a single thing, a single keystroke from your keyboard, and then you end it with another single quote. This is the character. So that means if you simply got a single quote followed by another single quote with nothing inside, that simply is not considered as correct syntax. Okay? And now, what can be put inside? Whatever that's available on your keyboard. Okay? There's a little bit of tricky things which I'll talk about at the end, so you don't have to worry, but that's the principle. Okay, for example, you can say character A. Okay, that's one. What about string? String is basically just going to be a sequence of characters. A sequence of characters. So now, since we know, let's be logical here. When I say it's a sequence, the sequence can either be empty or not empty, right? So now, in the case where we simply got an empty sequence of character that looks like this, I got a double quotes followed by another double quotes with nothing inside. This is actually a valid thing to have for string. It is so-called empty string. Okay, you might find this empty string useful sometimes. Okay, it's simply empty. You cannot have an empty character, but you can have empty string. Okay, so now, and then you can have as many characters as you like. For example, I can also have, let's say, double quotes followed by A and this. Okay, now I want you to pay attention to this. This guy here and this guy over here, okay, they are same, they are also different. They are the same in the sense that if you try to say system.out.println to print out a single character A or to print out a string containing only A, they will look the same on the console. However, if you try to compare these two values together, it's considered as a type error, which I'll explain later in the slides. Okay, just pay attention to that. Okay, the same console output but different types. Okay, that's my point. Okay, you can also have as many as you like. For example, you can also say A, B, C, D. Right? We have seen this a lot in the tutorial. I just want to mention again. Character, string, they're different. They're same and also different at the same time. So now we got string literals. Okay, just double quote. I said it already. And we also got integer literals. One thing to note, you can also got negative sign. Basically, the way you write integers, just like how you write in math. Okay? And floating point literals. Floating point simply means there are two parts for your numbers, fractional part and also integral parts, and also fractional part with a decimal point in between. Also, you learn about that in math. Okay? Now, I want to show you something that's very useful over here. For example, this is something you know how to write already. And also you can say something point something. And now this is a scientific notation you possibly know already, right? From your maybe calculus course. In that case, the E over here is simply exponents. And then you can say the power over here can be positive 2 or it can be negative 2. Okay, it's very easy to do. Okay, so hopefully the examples are clear enough for you. Any question about literals? Okay, literals are very easy to do, but if you only define your programs using literals, it cannot be very useful, cannot be very exciting. So that's why we had to learn about variables. Okay, that's something we'll get into. Okay, after literal, let's talk about operations. Okay, so now I want to clarify some terminology over here. So over here you can see just a single sentence. There are 3 terms you have to know about what they really mean. An operation refers to the process of applying an operator to its operands. Okay, you see these 3 words over here. Okay, I'll explain to you on the example. We got operator, we got operands, we got operation. Okay, so now let's use these 2 examples over here. So we got example 1, we got example 2, right? 2 examples over here. Operator, first of all, is simply just the kind of manipulation you would like to do. For example, multiplication and also less than. So these are operator. Okay? Now, for operator, typically, operator must manipulate on values. But how many values are they supposed to manipulate? It depends. Okay? For example, typically you will just get so-called binary operator. For example, in this case, star specifically is called binary operator. Okay, binary operator simply means you have to apply the operator to 2 values. Each one of them is called an operand. Okay, let me just print it out, point it out. So you can see this value over here is so-called the left operand. Okay, and these values over here are so-called the right operand. Okay, and now if you combine operator together with the operands, it's so-called operation. Okay, so now one more thing to say. So now if you say 3 multiply 7, the blue one over here, this is so-called a operation. Okay, so now hopefully the distinction is clear, right? Operator, operands, and operation. Okay, you can read them over here, just the notes. Okay. Okay, guys. All right. Okay. Right. So let's do a little bit more illustration over here. Okay, so that's about the operations over here. Okay, you can read them through. So now, let me just say this. For numerical operations, there's many kinds of operations. Let's just go over them quickly. Numerical operations, they are simply just numbers for their operands. It can be plus, minus, divide, and also modulo, which we learned about, right? So now, I'm going to mention a little bit more. Whenever you're trying to do a division over here, as we said in the tutorial, if both operands are integers, they will give you quotients. Right? If at least one of the operands is not integer. For example, you can see 13.0 over here is not an integer. It's a floating point. It got a decimal point. It's a fractional, has a fractional part. In that case, it will give you some precise result. Okay? Compare these two examples very carefully. Okay? And then we got something, also got modulo, which will give you remainder. And also, one thing to note, when we got something like this, okay, when I got minus 45, okay, this is something you may have not been aware of. Let me just apply the same concept. So the minus over here is so-called a unary operator. Unary operator in the sense that it only expects one operand, which means 45 is the only operand that this operator is expecting. And then the whole thing over here is so-called unary operation, right? So this whole thing over here is a operation. Okay, just apply -1, change the sign for the number. Okay? Okay, let me finish this and then we'll be done. Okay, finish this. Now, let's say we got relational operations. Relational operation, basically, we'll talk about true and false in a more formal way next time. However, relational operations simply just compare to see which one's larger, which one's less than or equal to, less than or larger than, right? True or false, okay? So for example, 3 less than or equal to 4, we know it is the case, so it's true. 5 less than 3 is not the case, so it's false. Okay, and also, one thing to know, equals simply means mathematical equality. You want to compare the values between two things. Okay, equals. A very common mistake is simply just write a single equal sign. That's not right. Okay? Okay, finally, let's see string concatenations. That's also something we mentioned in the tutorial. When you try to really have a plus in between string literals, it simply means to really concatenate all the strings together. Okay, any questions? Okay, I will start from this next time. Okay.